All right, hello everyone. Sorry it took such a long time for me to make the videos, but better late than never, right? So happy New Year, and so I'm going to be talking about vectors today, since a few people asked me about vectors. So I just made a brief explanation of a simple example, and hopefully it'll resolve every problem. So the question is, vector A has magnitude of 12 meters in the positive y direction. Vector B has magnitude 33 in the negative x direction. Calculate magnitude and direction of A plus B, A minus B, and B minus A. Like every other physics question, the first thing you want to do is 1. Draw a diagram, and 2. Extract information and change it to math. Okay, so let's draw this. So vector A is magnitude of 12 in the positive. So if you take up to be positive, as we usually do, you draw A in the positive direction. And it also mentions that B has magnitude of 33 in the negative x direction. So if this is positive, if right side is positive, left side is negative, okay? Keep in mind that the numbers are not scaled with the actual drawing, okay? So um, just keep that in mind. And also, I want you to pay attention that since these are in the y and x axes, this angle is 90 degrees, okay? It's not mentioned in the question, but you should be able to derive that, okay? So how do we actually do this? So there's two methods to do vector addition and subtraction. And the first one is called parallelogram method. So I redrew the shape that I drew in the previous slide, which is as follows. Now I want you to pay attention that the tails of these two vectors are connected, right? The arrow part is called the head of a vector. This part is called the tail. Now pay attention that in the parallelogram method, the tails of the two vectors have to be connected to each other. Okay, so you got to associate parallelogram with the tails being connected. Now how you actually draw the resultant, or the A plus B, is you draw two parallel lines, okay, two parallel dashed lines. One line is parallel to vector A and one line is parallel to vector B, right? And you can see that you've actually formed a parallelogram, right? This, I know you're all going to say this is a rectangle, but if you remember from your geometry class, which is wishful thinking, but you know, maybe one or two of you, uh, rectangle is a parallelogram. So what you do then is you draw the resultant by drawing a vector from here all the way to here. So from the point of intersection of the vectors to the point of intersection of the dashed lines. Okay, and this is A plus B. Simple as that. Okay, and by just drawing, you need to fully understand the geometry of A plus B and A and how you actually do it. Okay, and the resultant formula is a squared square root of a squared plus b squared plus 2ab cosine of alpha, where alpha is the angle between the two vectors. Okay, now the angle here is 90 degrees, and if you remember from trigonometry, cosine of 90 is 0, so the answer becomes square root of a squared plus b squared. Okay, and this is the magnitude of a plus b, and when you draw it, you get the direction. Okay, hope this makes sense. So we're going to go to the triangular method. Okay, the only difference between triangular method and parallelogram method is the following. That, remember, b was here when we did the parallelogram method. To do the triangular, we moved b here. And what's the major difference is that now the tails are not connected anymore. The head of A is connected to the tail of B, right? So you need to associate triangular method with the head of A being connected to the tail of B, and how you actually draw the resultant vector A plus B is you actually draw a line, draw a vector from the tail of A to the head of B, like following. Okay, this is vector A plus B, and this is the triangular method. I know People have preferences, but it's actually good to know both ways. Okay. But what I would do is I would master one of them and then also go and learn the other one. They're very interrelated, so the magnitude formula stays the same. As you can see, a squared plus b squared. Alpha is still 90, so you get the exact same answer as the parallelogram method. Okay. If you didn't understand the methods the first time, go back and look over again and make sure you fully understand it, because you don't want to memorize. You want to learn how to draw the resultant geometrically. Okay. So now you're all yelling that we get it. How do we do a minus b now? Um, First of all, you don't. Okay, so there's that. But how you do a minus b is everything. If you know those two methods, doing a minus b, b minus a, any kind of vector manipulation, you can do it if you understand, right? So a is a, right? Nothing has changed about a. But now you have a minus b, right? So what does minus mean in geometrically? Minus means that it's going to be in the opposite direction. Okay, what minus means geometrically is you're going to flip the direction. Okay, so if b was facing upwards, now it's going to be facing downwards. Okay, now the question that I'm asking you now is, what kind of method should we use? Having the vectors that we have right now, what method should we use to draw the resultant? If you know the answer to that, it's good. If you don't know, then maybe go back and listen again. So since the head and tail are connected, we're going to use triangular method, right? And we're going to connect the tail of A to the head of B, and we're going to get A minus. Now, I want you to pay close attention. What we're actually doing, right, is doing A plus minus B, right? So when B was this way, we drew the resultant like this, and we said that's A plus B. And now since B is facing downwards, we're doing a plus minus b, and as you all know, plus minus just becomes a minus, right? So to do vector subtraction, you're not actually doing anything new, right? You're just doing the same thing, except now b becomes minus b. Okay, I wanted to show you this so you have a better understanding. Okay, so now let's do the same thing using parallelogram method. Now we bring B from here all the way here, so the tails are connected, right? And then we're going to draw parallel lines to B and parallel line to A, and we connect the intersection of the two vectors, the intersection of the dashed line. And you can see that both of them are the same, right? And the magnitude formula is exactly the same. Okay. Now my question for you guys that you need to try to figure out is, why is the magnitude of a minus b exactly the same as a plus b? See if you can answer that question, and maybe leave it in the comments. And you need to tell me why. Why is it that a plus b has the exact same answer as a minus b? Now, and now you ask me, how do you do b minus a? Well, the answer to that is simple. You do it by following the steps mentioned below. You do it by trying yourself. Yeah, I'm not going to give you all the answers. You should be able to do b minus a based on how we did a minus b. Okay, I hope that you learned something, and good luck.